I gave up.
Alright. Listen, guys. Sorry, I had to turn on thing. It says this is a concentration problem. It says acid. It said acid up in the numerator, but this could be anything. It could be like the amount of Kool-Aid powder divided by the amount of total Kool-Aid solution or something like that. It could be anything. Anything you care about divided by the total volume. Right? It doesn't have to be acid necessarily. But it is kind of classic to think about concentration and think about acid. All right, so the point is we can come up with this concentration function, and that's what I'd like to do right here. Before we get going too far, we'd like to define an x value of some kind here. Let's think about, there is a variable here. How much pure acid must be added? So let's let x be the amount of acid added in milliliters. Right? So if that's the case, then, and in some other problem it could be that we're adding water, in which case maybe we let x be the amount of water added to the mixture. Okay. What is the concentration now? We want to come up with a function that gives the concentration for any amount of x milliliters of acid that you might add. Now I'm actually going to start with the bottom because I think that's easier. Let's look at the denominator first. What is the total amount of stuff? Now when x is 0, when you haven't added anything, how much stuff is there, does it say? A total of 50 milliliters, right? And if you've added 10 milliliters of acid or 10 milliliters of water or 10 milliliters of anything, then how much stuff is there now? 60, or in general, if you add x, 50 plus x, right? So the amount of stuff is 50 plus x. Total amount of solution. What is the amount of acid? Okay, let's start by thinking how much acid is there when x is 0, like when there, before we ever add anything. How much is there at the beginning? So how do we actually compute that? Yeah, it's 0.35 times 50, right? Is that the amount we have at the beginning? But then, wait, how much do we have? So this is the concentration at the beginning. If x, right, it's just 0.35. But if we add x milliliters of acid, then how much acid do we have up in the numerator here? We have this amount from what we had at the beginning, which is 17.5. What is 17.5? Plus the amount of acid that we added, right? So does that do it for us? Again, if x is 0, if you've not added anything, then this should return 0.35, does it? If x is 0, doesn't this spit back 0.35? Good. It's doing that for us well. If you plug in like 10, it should give us the concentration when you've added 10 milliliters. Do you agree that it's kind of working for you? Look at it and make sure that it kind of makes sense to you. Does it? Because you have 10 milliliters of acid. The total volume, if you add 10, is 60. And on top, you have 10 milliliters of acid plus the amount of acid right here that you started with. Okay? All right, and then the question comes in. What would it have to be for it to be 75% acid? What would x have to be? And that's equivalent to asking the question, solve this equation when it's set equal to something. 0.75, right? If we're thinking of concentrations as being things between 0 and 1, between 0 and 100%, 0% and 100%. So solve this equation using your powers and give it an answer, and you'll be done. Okay? The setup is the thing I wanted to like hone in on. So solve this, and actually we should say something about how you might solve it. You could solve it using some algebra, and it's not terrible algebra. Go ahead and do it. Or you could also, if you have a calculator in your hand, you could actually graph the left side in y1.
It's so cheap.
And graph the right side in y2. It's a horizontal line, y equals 0.75 and y2, right? And find the intersection. Either way, you should get x equals something. I don't know. Someone solve it. Yeah.
Why wouldn't it be equal to 0.75 times 50?
Times 50?
Yeah.
Well, we don't know what the volume will be at the end. We want the concentration. Like we want this is a function that gives the concentration a number that like between 0 and 1. So if you plug in 0, for example, you get 0.35, which is good because 0.35 that's the concentration when x is 0. When you haven't added anything, we're told the concentration is 35%, right?
Yeah. Okay, okay.
Does that make sense? And someone in a second is going to tell us what x is, and then
It's 80.
is it 80? Okay. So what we're claiming is that if x equals 80 milliliters, you can try this. You can try this. Plug in 80 for x here and here, and it should be true that the new concentration is 0.75, which is what we want. Yeah. The new volume is much bigger. It's actually, what is the total volume? 13. It's 130, right? 130 milliliters is the new volume. If you solve this on your calculator, you'll get the following graph, right? 0.35 is the y-intercept, right? And then the concentration goes uphill, doesn't it? Tell me about this graph. What is true about this graph?
Oh, it's the cube root function.
It has a horizontal asymptote where at? What is the horizontal asymptote of this concentration function? It's y equals what? 1. Does it make sense that it would be 1? Why?
You can't have more than 5%.
Yeah, as you add more and more and more and more, and an infinite amount maybe even of acid, your concentration approaches, what does 1 mean? 100%, right? Which we can, so we can get as close to 100% concentration as we want, theoretically at least. Okay. All right, the other one example that you'll maybe encounter in night 2. What's that? What'd you say? All right, so like I said, I have 2 slides for you today. If you guys would stay with me, please. The other thing I want to say something about is average cost. All right, so this is something that comes up tonight as well. So say you're starting a lemonade stand, okay? It costs you $500, say, for, because this is like not just like your average lemonade stand. Whoa. Average lemonade stand. This is like a serious lemonade stand, okay? $500 is what your setup costs are going to be, including like your beautiful pitcher. You're going to get like an artisan glass handmade by a guy in Kensington that you know. You're going to have professional signage made by your art friends. You're going to pay, right? You're going to get this nice, all that's going to be a fixed, in economics you might call it a fixed cost, right? $500, only have to pay that once. Whether you make 0 cups of lemonade or whether you make 1 million, it costs $500 for all of those things, right? Only one-time fee for all that. You also, though, incur the following, what economics people would call a variable cost. The following variable cost. You incur a cost of 20 cents per cup. Okay. So if you were like in Algebra 1 class, and I asked you for the total cost of producing X cups of coffee, lemonade, I mean, what would the total cost be? Don't look at this equation yet. What would the total cost be? It'd be 500, what'd you say? That's, of course, always going to be in there.
Times 0.2x.
Times 0.2x?
I meant plus 0.2x. The
Plus
first set.
0.20 times x. Yeah, exactly, right? Does that make sense? That's like I said, kind of algebra 1 point, slopes, y-intercept kind of problem. We can think of 500 as the y-intercept, and we can think of 0.2 as the slope. All right, wait, hold up. But now I'd like to ask the following questions. I'd like to think, what would happen if you made 10 cups? How much would it cost you? And actually, I'd like to know, what would it cost you per cup? Because that's really what I want to care about, right? It's going to cost me like, what would it cost for 10 cups?
500.
We'd like to know what is the cost per cup, right?
Shoot, I forget.
All right, coming up with that equation is the most important part. I don't think it's that important to have answered those questions before you go. The word average cost will come up in the homework. I just want to make sure you know what it means.